Postgres gives you 4 guarantees every time you wrap work in a transaction. Let's go under the hood and see exactly what each letter means and what breaks when a developer ignores one. Atomicity, consistency, isolation, durability. Each letter patches a different failure mode. Postgres implements them through its transaction manager, constraint system, MVCC engine, and write-ahead log. When transaction 712 runs a transfer, Postgres writes new row versions for both accounts. If the transaction aborts, those new versions identified by the xmin of 712 become invisible to everyone, leaving the original rows untouched. Consistency means the database refuses to commit a transaction that leaves constraints violated. Postgres checks them on every write by default or at the end of the transaction if you mark them deferred. Postgres implements isolation through multi-version concurrency control. Every row can have multiple versions and each transaction snapshot determines which version it sees, so readers and writers never block each other. Transaction 800 snapshot was taken before transaction 801 committed its update. So transaction 800 still reads the old balance of 500, while transaction 802, which started after the commit, sees 650. Neither transaction is blocked. Durability is enforced by the write-ahead log. Postgres records every change to the wall and FSYNCS it before acknowledging a commit. If the server crashes, recovery replays the wall to restore exactly what was committed. We start a transfer that moves 200 from account 1 to account 2, then rollback. Selecting both rows afterwards confirms atomicity, neither account changed. The partial updates never made it to a committed state. The classic PR mistake: 2 update statements issued without a begin. Each one auto-commits, so a crash or application error between them leaves one account debited and the other never credited. Always wrap multi-statement operations in an explicit transaction. In a review, look for multi-step mutations outside a transaction, deliberate weakening of synchronous commit without a documented trade-off, and isolation levels that are too loose for the business logic they protect.